chemistry. Martin and I are barreling here through the practice problems for Module 10. We're moving on to number 9.
Thunderbolt fired from
Thunderbolt.
Pikachu.
There's no Pikachu. Number 9.
A chemist needs to know the concentration of some NaOH that is in the laboratory. To find this out, she titrates a 50.0 milliliter sample of the solution with 3.5 molarity HCl. If it takes 34.3 milliliters of the HCl to reach
Sorry, how many?
34.3 to reach the titration endpoint, what is the concentration of the NaOH solution?
Ooh. Good. This sounds fun, huh? Okay. So this is stoichiometry problem. So the first thing we have to do is set up a balanced equation. Okay? So we have HCl, NaOH. What kind of reaction is this? This is an acid-base salt-water reaction, right?
Yeah.
Okay, so we're going to have NaCl and H2O, right?
Yeah, I know NaCl.
You do. It's just salt,
like
table salt. That's right.
And you were saying that this salt isn't necessarily table salt.
No, I didn't say that. I said it's not necessarily table
That's
salt.
what I said.
I didn't say it never is table salt. I said it doesn't necessarily.
It's not necessarily table salt.
You know, you're being kind of obnoxious.
I think I'm being funny. Because you misheard what I said, so it's pretty funny.
Okay.
But I was actually saying the correct thing.
So, did we reach the endpoint of the titration?
So apparently.
Yes, that's what it says, right?
Yes.
To reach the titration endpoint. That means that there was enough acid and base to use each other up.
Yeah.
Right? Okay. So how many moles of the acid did she add? We know the molarity, we know the volume. So we're going to use that information. Molarity equals number of moles for number of liters. Okay. So we want to find out how many moles she used. The number of moles is going to be equal to the molarity times the number of liters, right? It's going to be 3.5 times, I'm going to switch my milliliters to liters, 0.0343 liters. Okay, Martin? Calculate this for me, please, young man. 3.5 times 0.0343.
0.0343 is 0.12005.
0.12. Hello?
005.
What's after that?
Nothing.
Okay. So I can only use two significant digits, so 0.12. Okay, the number of moles. And this is, of course, the HCl. If that is the case, how many moles of the NaOH are used?
Then 0.12.
Right, because it's 1 to 1. We have a balanced equation here, right? We already worked it out. So that's why it's really important that you balance your equation, because if you don't balance your equation, then you're not going to get the right ratios. So we did balance our equation. So we're using 0.12 moles of this. How do we find the concentration?
It's moles over liters.
It is. How many liters?
0.05.
That's correct. So now we're going to divide 0.12 moles of NaOH by 0.05 liters, and that will give us
molarity.
The molarity. Molarity equals 2.4. Isn't that fun?
Yeah.
So the initial solution, the NaOH solution that she's working with, has a concentration of 2.4 molarity. Okay, and now number 10. Too much fun. Are you in search of good times and good friends, vacations that don't
Oh, yeah.
end?
I love vacations that don't
Yeah,
end.
this could be a habit. Number
A
10.
solution of H2SO4 is titrated against 1.2 molarity KOH. A total of 345.1 milliliters of KOH must be added to a 500.0 milliliter sample of H2SO4 in order to reach the endpoint. What is the concentration of the H2SO4? Do you think we could stay in Florida for like a month?
Do you know we're making a video right now? Thank you so much. Okay.
I'm bragging twice a day.
So we're going to first write an acid-base salt-water reaction. Why?
Because this is stoichiometry. and
So
we must be
true.
stoic.
Oh, you're so right. H2SO4 plus KOH yields and water. Okay, what's our salt? Is going to be K2SO4. It's not balanced yet, though, is it?
We need to double that one.
Right? Looks balanced now, doesn't it?
Yes.
Okay. So, we can figure out how many moles of KOH we use, right?
Yeah.
How can we figure it out?
Molarity formula.
Yes. So the molarity is the number of moles
times
per
over
number of liters.
liters.
So since we want to find the number of moles, it's going to be the molarity, which is 1.2, times the number of liters, which is 0.3451 liters. Okay, and I'm not actually going to use liters because I'm just any numbers of moles. So I'm not worried about my units right now.
0.41412.
0.414?
Yeah.
Okay, so we're going to say 0.4 moles. Excuse me, 0.41? Is that what I said?
41412.
Yeah, the 0.41 moles. Okay?
Okay.
So that is how many moles of KOH we're using. Okay. Let's look at our reaction. If I use 2 moles of KOH, how many moles of H2SO4 do I use?
1.
1. So I'm going to use half of this. So
Okay.
let's divide this by half, or multiply it by 1/2. So that gives us
205.
Which is going to give me 21 because I can't have 3 digits. I can only have 2. I'm going to round to 21. So it's 0.21 moles of H2SO4, right?
Yes.
Okay. So for every 0.41 moles of KOH I use 0.21 moles of H2SO4. I use half the amount. Okay. So now what? We're still not there yet.
Yeah. We need molarity.
Well, I know how many moles I've used.
Yeah.
I know how many liters
Okay then.
I've used. So all I have to do is find the concentration.
So 0.
Okay. So the molarity is going to equal 0.21 moles. And remember, this is milliliters.
Mm-hmm.
So make it 0.5000 liters.
It's 0.42.
So the molarity is 0.42. And that is the molarity of the H2SO4. And that's it. Hooray! Module 10, number 10, we're done. High five. Low five.
Up high. Too slow.
Who are you? My little berry.